Hi everybody, welcome to Unit 7 Linear Regression. Today we're going to talk about correlation coefficients and bivariate data. The first thing we're going to do today is we're going to do a little exploration on your Chromebooks. I'm going to walk you through how to do this, and then I'm going to have you pause the video and you can go ahead and play around with these. So the first one we're going to look at this is this Our Psychologists Today site. What you're going to do is you've got this thing here that says Slide Me. This is your landing page. This slider is going to be right in the middle of your page, and you're just going to grab it and slide it left and right, and you're going to see what you can figure out there. The other site you're going to go to is this rossmanchance.com site, and you're going to try and guess the correlation coefficient after having taken a look and seeing what happens here. So this is what that site looks like. And you can put however many points you want in here. I'm going to start with 25. They'll give you a new sample if you press this button, and then you just go ahead and guess your correlation. So take a moment, pause the video, and when you get done, come on back and we'll talk through what you should have seen. Welcome back. Taking a look at this website, what you should have noticed is that the closer you get to -1, the closer your data is to a line. The closer you get to 0, the less like a line it is. This is scattered all over the place. And then finally on this one, the closer you get to +1, the closer your data are into a line with a positive sloping variable. And then guessing the correlation coefficient, for example, when I look at this one, this is a negative sloping. I'm going to call that maybe a -0.7. So when I type that in, I'll check my guess, and I was not too far off there. So that's what you should have found on your exploration with those two applets. So bivariate sampling, that's what we're going to be looking at here today. Bivariate sample, bi meaning two, like bicycle or biped. It's two variable sampling to determine a relationship between the two variables. So is there something actually happening there? And correlation coefficient, that's a measure of the interdependence of two random variables that ranges in value from -1 to +1. What you should have seen on that first app is that you can never go lower than -1 and you can never go higher than +1. So there is your continuum. The closer you are to 0, the weaker your correlation coefficient is. The closer you are to 1, or the closer you are to -1, the stronger your correlation is. This is a strong negative correlation. This is a strong positive correlation. So we are going to move each term to the correct place on our continuum here. So I'm going to look, I've got perfect negative correlation. That's going to be at -1. I've got perfect positive correlation. That's going to be at +1. Strong negative is going to be close over here. Strong positive is going to be close over here. Weak positive, somewhere in this area. Weak negative, somewhere over here. And no correlation is going to be at 0. So again, the closer it is to 1, the closer it is to -1, the stronger your correlation is going to be. All right, so now we need to match our correlation coefficients to our scatter plots here. I notice that I've got two negative correlation coefficients, so I'm going to take a look at my graphs. This one seems to have a negative slope to it, as does this one. So we're looking at A and F, and we're just going to do a little process of elimination here. This one seems to be closer to a line, so I'm going to put my correlation coefficient of -0.95 there and -0.84 here. So now I'm looking here, these are my 4 positive, and I'm going to look for the one that's most like a line, and that seems to be this one here. So I'm going to put my 0.97 there. Now between these two, which is more like a line, I think this one here is probably more like a line, so that's my bigger of the two numbers, closer to 1. And finally, this data, a line does not fit that data very well at all, so I'm going to put my 0.09 there. So now, the following situations, how would you expect to find a positive correlation, a negative correlation, or no correlation? Number of calories consumed and weight. That's probably going to be a positive correlation because generally speaking, the more calories you consume, the more you are going to weigh. Hours of sleep and age. Most of you would probably say that babies sleep a lot more than teenagers, so that would be a negative correlation. And then accumulated wealth and age. Generally speaking, the amount of wealth that you have will go up with your age, so that is going to be a positive correlation. All right, we are going to look here. Oh, hold on, we need to move back a minute. Sorry, I forgot this. Positive correlation, as your x increases. So if you are going on a graph here, as your x increases, your y is also going to increase. And a negative correlation, as your x increases, like on this graph, your y is going to decrease. All right, let's take a look at the summer camp data here. The director of a summer camp has collected data for 2 weeks on both daily ice cream sales from the camp store and visits to the camp nurse for treatment of sunburn. If I take a look at this data here, this is a lot of ice cream sales. That seems to be quite a few number of visits to the nurse. Similarly here and here. Whereas this is a low amount of ice cream sales and a low number of visits to the nurse. Similarly here. So they did find a positive correlation when they graphed this data. But can you conclude that buying ice cream causes sunburn? Or does getting a sunburn cause ice cream buying? Well, of course not. But there is something happening there. There's most likely another variable causing both of these effects. Perhaps the daily temperature might be what we call a lurking variable behind both of these results. So something else is happening. Buying ice cream does not cause a visit to the nurse. A visit to the nurse does not cause buying ice cream. There's something else happening. And generally speaking, when it is nice and hot outside, like we have in our Minnesota summers, we are more likely to be out in the sun, and we are also more likely to buy some ice cream. So now let's take a look at a couple others. What could be the lurking variable in these examples? As ice cream sales increase, so do the number of drownings. So does ice cream cause you to drown? Well, no, of course not. Again, that one could be the weather. And then this next one here, a certain data set showed that taller adults have higher annual salaries. Does height cause you to earn more? Take a moment and ponder that. There might be a lot of things happening here. Height does not cause you to earn more. Perhaps the data included basketball players or other professional athletes who are taller. Perhaps the data had men versus women, and generally men are taller than women, and many times men make more money than women. So there could be some of that happening. What you need to know here, though, is that correlation does not mean causation. Okay, just because there's a correlation doesn't mean that one thing causes the other. Okay, we don't have the math skills in our class to be able to determine this. That'll be something that you'll look at in a higher level math class. Okay, so here's a table that shows the number of losses, Y, that a gamer has X weeks after getting a new video game. So here we are. These are our weeks. These are our losses. We're going to graph the data on the scatter plot. Take a look, is there a positive, negative, no correlation, and then estimate your correlation coefficient. So what I'd like you to do, pause the video, plot this out, and then answer those questions. Welcome back. As you can see, I've plotted the data here. You can very clearly see that this is a strong negative correlation, and I would say that this is probably about a 0.9 on the negative 0.9 would be my estimation of the correlation coefficient, because it is very much like a line. All right, so what you guys need to do, you need to do correlation worksheet number 1 in your packet. Thanks for watching.